So I'll start by just providing a little bit of an event background. A few of us really just took a look at the landscape for data science and artificial intelligence, and really just came to the realization that although there's a lot of resources, training, and stuff like that, for more from the high level of AI, and also quite heavily focused on the technical perspective of AI, there wasn't really a lot from a project delivery perspective. And so what we wanted to do is we wanted to put together an event that that would help just demonstrate how to deliver business value and solutions to project stakeholders, just because it's slightly different doing those kinds of projects when you're leveraging AI. We also wanted to find different ways that we could help BAs, really the folks that are in the trenches working on the projects, to continue to be the strong facilitators and trusted advisors that that they really strive to be, giving the BAs some really tangible tools and insights that they could take back to their projects and really use and have something useful. That's really the goal of today's event. And so we'd actually also like to just request that any of the questions that you pose for Kevin at the end of his presentation, if you could just stay focused on the project delivery aspect and not on the ethical and the impacts to society type questions. I know that there's a new Terminator movie coming out, so I know everybody's excited about that, but that's a different discussion. And funny enough, I was recently reading Brené Brown's latest book, Dare to Lead, and she mentioned artificial intelligence, and I'm just like, wow, this really is mainstream, like everybody's talking about it, so that's great. And I thought it was really interesting. She used a reference to a quote from Yoda, and so her quote from Yoda was, well, as she was talking about fear in the book and stuff, she said, so Yoda says, the cave that you fear to enter contains the treasure that you seek. So it's kind of like with AI, it's kind of scary because we don't really know what's going on in there, but at the same time, we're really going to need to understand what's going on behind the curtain to make sure that that we're staying competitive in the market, regardless of the organization that you're really a part of there. And so at this time, I'd like to introduce our guest speaker, Kevin Dewalt. So Kevin is CEO and co-founder, technical lead for all client engagements at PROLEGO. Kevin has a distinguished career with 30 years of experience as an entrepreneur, engineer, and tech investor. As the CEO of PROLEGO, he helps the companies use AI to generate billion-dollar revenue opportunities. He's also the author of a book called Become an AI Company in 90 Days, which is the most widely read business book on AI by Fortune 500 executives. So Kevin holds several degrees. He has a degree in electrical engineering from the U.S. Coast Guard Academy. He has a master's degree in electrical engineering from Stanford. He has an MBA from University of Maryland. And he recently delivered an AI podcast. You can find that podcast on dataengineeringpodcast.com. He also recently delivered an AI bootcamp webinar for MIT. He's based out of Savannah, Georgia. So let's give Kevin a warm welcome to the IIBA community. I'll switch over to your presentation there, Kevin.
Okay. Well, thanks so much for the welcome, Ted. And while you're doing that, I just want to say thank you so much for making this so easy. I really appreciate the organization and the time that went into planning this event. Okay, so I'm going to share. Okay, while it's coming up, I'll just say a few words to start with. I took a look at all the questions that were put together in advance, and these are really common questions we get from a lot of our clients. Hopefully, we'll be able to answer most of them in the presentation today. As Ted said, I'm from PROLEGO. My business partner, Russ Rands, is also on the call. He's in listening mode. He's currently on travel right now. We're a boutique AI consulting company, so we work with like Fortune 500 or Fortune 1000 companies and help them get started in AI. And that usually involves training, the kind of, you're going to see an example of that today, strategy, helping them figure out what they can do with AI. And we also do all the technical work, the developing models and then putting things into production, all the software associated with that. So we've been in business for about 3 years and pretty much seen just about everything that a big company needs to get done to get started with AI. You really don't need to take any notes tonight. All the information I'm going to cover, we've captured in our book. You can download a free PDF off our website. It's the URL is right there. And I think in the way Ted introduced it, when we looked around the marketplace, we saw that there was a lot of like high-level, fluffy, often scary talk about AI, and there's a lot of low-level technical information in the details. We couldn't find a lot in the middle that helped business leaders understand what is this technology and how can I use it to make an impact on my job. So that's what we've tried to deliver in our book and in our presentation today. So hopefully we'll be able to answer as many of your questions as you had in advance, but if we can't, we'll tackle them at the end. Whenever we give a technical talk, we try to give people specific skills they can use. And so there's 2 skills that I want you to have today by the end of this discussion. First is I want you to have an understanding of what the AI basics are, what a model is, what machine learning is, what training data is, so that you can participate in a meeting. And if you have a client that talks to you about an AI project, you're going to be able to participate and add value to the conversation. The second is going to give you some basic heuristics for identifying AI opportunities in your organization. And if we have a little bit of time at the end, I'm going to show you a filtering framework, a canvas that we've created that's going to help you take these potential opportunities and identify the challenges and business value associated with them. Okay, so let's start off with AI fundamentals. So first, let's talk about why we're here. Those of us who've been in tech for a long time, about every 6 to 8 months or so, somebody's announcing some crazy, disruptive, newfangled technology that's going to take over everything, and it's an opportunity for people to sell books and conferences and consulting. But most of the technology that we see come out really only makes incremental or evolutionary changes to how we work. But about every 20 years, there's a technology innovation that comes out that changes everything. And I'm talking about things like electricity, the microprocessor, computers, the internet. And it's hard to imagine working in a world without these technologies because they really have changed everything about how we work and how we live. AI is one of those revolutions, and it's the latest one. For about the past 40, 50 years, computers have been doing primarily 2 things for us. They've been helping us work more efficiently, and they've been helping us communicate more efficiently. We're now entering an era where computers are going to start thinking for us, and that's going to fundamentally change how we work. And we're going to have thinking computers embedded in everything we do in every single business process. And so it's massively going to disrupt how we work. And the era that we're entering is that computers are going to begin augmenting, in some cases, replacing human-level thinking and intelligence in all the systems that we design for clients. So that's the scale of the disruption. That's why you hear people keep talking about this and talking about it. Why there's so much excitement? It's because people recognize it's like the internet. And the internet, I'm old enough to have been coming out of grad school right when the first web browser came out. So I remember how transformative it was, but at the same time, how much confusion there was and misconception and how much hype, and how people were kind of hungry for this thing called the internet. They wanted to get a hold of it, but it wasn't very accessible at the beginning. Well, that's where we are with AI today. AI today is like the internet in 1997. We're at the very beginning. But fortunately, in the last few years, the technology has evolved to a point where you can start applying it in some of your projects at work. So let's get a couple definitions out of the way. First is the definition of AI. AI just means intelligent computing. I use it as a very general term, just like I would use the internet or electricity. On itself, it doesn't mean anything, and I use that term when I deliberately want to be vague. Machine learning is a type of AI, and it's a different way of building software. So we're going to spend a lot of time today talking about machine learning. Deep learning is a type of machine learning, and it represents the state of the art in AI. So most of the whiz-bang developments that you hear and read about are based on advances in machine learning. I'm sorry, in deep learning. So before I describe what machine learning is, I'm going to take a few minutes to describe what machine learning isn't. 99% of all software, I should say 99.99999% of all software that is built today is not using machine learning. And if you've been a business analyst for a while and you work with big clients on software projects, you're probably used to doing projects without machine learning. And so here's an example of a very simple software program written by a developer. So a developer actually sat down and typed out this pseudocode and told the computer what to do. And that's how all software is built. So this very simple pseudocode, if you've done any kind of programming, you can see that it spits out the time once a minute. And this is a very simple software program. Now, my question for you as a business analyst is, how did the engineer know that they should run this particular software loop from 1 till 10? And why didn't it go 1 to 11? And why did it wait 1 minute before printing the time again and not 59 seconds or 58 seconds or 102 seconds? And I don't have to ask you why that is, because we know the answer is a business analyst wrote a spec for them that they followed to be able to write the software. So one way or another, somebody told this developer what they wanted the computer to do, and what they wanted the computer to do, and the developer went and wrote the software to cause the computer to do what is required. And that's how 99.999% of software is built, by a developer explicitly telling a computer what they wanted to accomplish. So that's how software is created without machine learning. In machine learning, a developer uses data to train a model how to perform a specific task. And so we're going to come back to this definition a lot, but I'm going to start off by first giving you an example. Suppose that you have a customer, maybe they work in government, and they want to design an intelligent signal alert system. So you can imagine that this particular customer has a bunch of sensors, and these sensors are scattered all over the world. Maybe they detect pressure or temperature, time, vibration, whatever you can imagine. And these sensors all send signals back to a group of analysts. And the analysts don't want to spend time looking at every possible sensor signal. They want to just look at the most important ones or the most interesting ones. And they want to spend their time in those particular signals. So if you've done any work in financial services or operations, a very common business problem, you have a lot of information flowing into an analyst, and you want to filter out just the most important information for that analyst to see. So let's talk about how we would build that particular piece of software using traditional software programming. Well, a business analyst might sit down with the customer and say, okay, what makes an interesting signal? And the customer might say, well, if the signal is in an important region, like a particular part of the world, it's interesting. If it's in North Korea, it's interesting. If it's in the middle of Idaho, probably not so. If the sensor is not having a maintenance problem, not spitting out garbage data, then it's important. That's interesting. And you can imagine on and on and on. And you can sit down with the customer and you can have a dialogue about what makes an interesting signal. And then a programmer goes and takes that information, takes that specification, and it programs code like this into the computer to teach the computer what it wants it to do. And then you have a software program that can help identify an interesting signal for an analyst. Now, for simple problems, this type of programming works great. It's quick. It allows people like developers to use their intuition to make something that works, but it also suffers from a couple of problems. First off, as anybody's worked on any big software system, you know that all software starts out really easy, but over time it gets harder and harder and more complex. And it gets more difficult to manage, and you get more lines of code and more updates and more patches. And soon you have an incredibly complex system. So increasing complexity is one problem with this type of software development. A second problem is that they don't tend to be very resilient. So if your underlying data starts to change, if your business problem starts to change, it requires people to go in and often completely adapt or completely redesign the software. And that takes a lot of time and can be very expensive. So machine learning has been used by software engineers as a different way to program computers to overcome this problem. So let's talk about what it would look like to do the same problem in machine learning. Now again, going back to our definition, in machine learning, a developer uses data to train a model how to perform a specific task. So if we're going to design the same system with machine learning, in step one, the analyst would sit down with a customer and say, okay, customer, I want you to take all of the interesting signals over the past 6 months, and I want you to put them in this CSV file. And I want you to take all of the not interesting signals you've seen over the past 6 months, and I wanted to put them in that file. And I want you to split up the data between what's interesting and not interesting without explicitly telling us why. You just, as the person who understands, you organize this data in a way that lets us know which ones we should automatically be able to detect. But a data scientist or a software engineer takes that training data, feeds it into a machine learning algorithm, looks at the results, whoops, gotta stop hitting the button here, looks at the results, and using feedback, it trains the machine learning algorithm how to predict whether a signal is interesting or not interesting. And this is how a developer creates software using machine learning, by feeding data into an algorithm, using feedback to train the algorithm to do what it wants to do. And after that training, the developer has built a piece of software that can automatically identify whether a signal is interesting or not interesting. And so this is a basic machine learning exercise called supervised learning, because the supervisor or the teacher is the person that organized the training data to feed into the model. If you get nothing else out of what I'm going to talk about today, then take the last 5 minutes. This is what machine learning is. It's a different way of building software. So when you sit down with your clients or executives and they say things like, in Q4 we're going to do AI and machine learning in our data lake, you're going to know that that doesn't mean anything. So you have to get to a bigger level of specificity to understand what a client wants to do, and that's machine learning. Let's talk a little bit about deep learning. So deep learning is currently the state of the art in AI and in machine learning. And if you really want a nice story that helps you understand why we're in this current era and why we're talking about this, it's about 2.5 years old now, but there was a story in the New York Times called The Great AI Awakening that describes how we arrived at this point after years and years and years of this technology really not becoming practical. Excellent article for those who want to learn a little bit more about this topic from a non-technical source. So machine learning is a type of deep learning characterized by 3 components. One is that it operates on very, very, very large data sets. The second is that it uses a particular type of machine learning algorithm called a neural network. I'm not going to spend any time talking about neural networks. The math is not terribly interesting. The algorithms have been around since the 1950s, but we finally have the business use cases and the technology to be able to take advantage of them. And because we have these large data sets and we have these large neural networks, we actually can't train these models using a traditional computing power. We have to use something called GPUs, or graphical processing units, to train these algorithms. So specialized hardware with GPUs, large neural networks, and large data sets constitute deep learning. So what? Why do we care? Why do we care about deep learning? Well, actually, there's 2 reasons. The first reason that deep learning is allowing us to overcome some traditionally intractable, very, very, very hard problems in computer science. In particular, computer vision, which is understanding what's an image, and natural language processing, which is helping us to either create or interpret human-generated language. We're going to spend a lot of time talking about each of those tonight. So it's allowing us to make fundamental breakthroughs in problems that have challenged researchers for decades. And that's why people were talking about, if you've done any kind of work in government or maybe in the hardware projects, how people were talking about things like, facial recognition for biometrics for decades, and it was always terrible, not that good, and seemingly overnight, all of us have it on our phones here to do facial recognition. It's because of deep learning technologies allowed us to make advances so quickly. The second reason that deep learning is so important is because it's great at handling incredibly complex problems. So Andrew came up with a graph, which I've sort of copied here, and it really illustrates the point of why deep learning is so powerful. So I have a chart here. On the x-axis, I have data. So data increases as you go to the right, and I have performance, which increases as you go up. So it's a measure of how good a particular algorithm or piece of software works as the data increases. What happens to the performance? So I'm going to talk a little bit about people, traditional machine learning algorithms, and deep learning. So let's start with people, Homo sapiens us, right? Now, if you look at that graph, human beings, we're great when there's a little bit of data. And that's because we have knowledge and intuition and judgment. And with a couple of bits of data points, we're able to make a leap and actually do a pretty good job of interpreting what's happening. If you take even a small child and you show the child a picture of a zebra in 1 or 2 pictures, the child can very easily walk outside or go to the zoo and notice that it's a zebra because the child's intuition. So we're great with small amounts of data, but as any of our, if you all have the aging brain that I do at age 49, as data increases, we don't do too well, right? So we don't get better with more and more data. If you show a child 150 pictures of zebras, you're not likely to get anything more than a temper tantrum from a child that's sick looking at the same pictures. So increasing data doesn't help. In traditional machine learning, the kind that banks and governments and intelligence communities have been using for decades, performance starts to go up as you add more data. So as you have more data to train the models, they get better and better and better. But at some point, that performance starts to fall off. And adding more and more data and more complexity, you don't get any more value out of it. And so a lot of the credit card fraud detectors and some of the work that the intelligence community has done, they've been using machine learning for 20 years. Those systems, reach limits just based on the amount of data. With deep learning, provided that you can keep throwing more hardware and bigger neural networks and more complex and more innovative algorithms at it, your performance keeps improving. So you can keep getting better and better by simply throwing more data at it. And we're seeing this happen in real time in the marketplace right now. There are breakthroughs happening in one particular domain that we're going to talk about, natural language processing. And you have IBM and Google and everybody and NVIDIA, they're each beating each other on the next NLP challenge by just throwing more hardware and more data at the problem. And so as you keep throwing more data, that's why deep learning is so exciting, because the performance and the impact we can make with this intelligence technology is really unlimited. So let's talk about our previous intelligent alert system. Once you have trained the system with deep learning, it allows you to take not just kind of the structure signals that come out of maybe the sensor you have, but allows you to take things like maybe aerial photographs from a drone and feed them into your machine learning algorithm and get a better job of figuring out whether or not a particular signal is interesting or not interesting. Okay, so those are some of the basics of what machine learning and deep learning are. I'm going to go over a couple of key concepts that are going to help you get started with doing a machine learning project at your particular company. We're going to talk a little bit about inputs, which is the data to feed a model, the output, which is what the model is trying to predict, and models themselves. So again, coming back to our definition, in machine learning, a developer uses data to train a model how to perform a specific task. So let's talk about the data and the model. So I don't know if anyone was paying attention, but when I talked about making our intelligent alert, our intelligent signal detection system earlier, I described step one. And step one is you have to sit down with a particular analyst and ask the analyst to organize the last 6 months of signals into interesting and not interesting spreadsheets. And if you've thought about that for a second, there's probably a couple of you in the audience that thought, that seems like a lot of work. I mean, depending how many signals these sensors spit out, IoT devices can fire off sometimes tens or hundreds of signals a second. So you can imagine that you could potentially have gigabytes or terabytes of data here. So trying to ask somebody to sit down and take a huge corpus of data and to organize into interesting and not interesting signals is one heck of a lot of work. And that's why acquiring, preparing, and training data is usually the most expensive, highest cost, highest risk, most complex part of any AI project. So if you start working on an AI project or you find yourself associated with one, you're going to very quickly find yourself in the realm of being a data analyst and trying to find experts to help you organize this training data. So let's talk a little bit more about the data. So the training data you have has two components. It has the inputs, and that's the information that feeds into the model, and the outputs, and that's what the model produces. Whenever you start an AI project, you want to start first by thinking about the outputs. What is it that you want these models to do? Every single machine learning model built in the history of creation produces exactly one thing, and that's a number. These are digital algorithms, and they all spit out a number. That number has to mean, or a series of numbers. Those numbers have to mean something. Maybe they represent a document space you're trying to classify. Maybe they're the prediction of a future cost of a resource. So before you begin an AI project, and when your client says you want to use AI on the data lake in the third quarter, one of your first questions you want to try to ask that person is, okay, what is the output you're looking for from that machine learning model? What are you trying to get the model to predict? What do we want these data scientists to do? And that's the first place you want to start thinking about your AI strategy, is by thinking about the output that you want out of the model. The second piece of data you want to think about is the inputs. So once a client has told you, well, we want to be able to classify a document and predict whether or not this particular email violates our compliance policies if it gets sent out outside the organization. Great. Then your question is, what is the input data we have? You want to start asking yourself, do we have the data that might be correlated with the output that we're trying to predict? And this is where a lot of time as a BA, your time will be spent analyzing data. Do we have the internal data sources? Do we have enough of them? Are there new data sources that we can possibly acquire? Is there a breakthrough in the research that's going to allow us to leverage things like unstructured data in emails or pictures that a customer has that's going to allow us to leverage as an input signal? And so you want to start identifying potential inputs that could be predictive of your outputs. And usually at the first pass of an AI project, this doesn't require a ton of technical analysis. It's mostly sitting down and thinking about what you're trying to accomplish. Let's talk a little bit about models now. There's a lot of confusion about models, and they sound all scary when people talk about AI models. And if you go to any kind of AI conference, everybody wants to talk about models and what they're doing. But for most stuff that we're going to work on for a business context, really the more interesting part of it is the input and the output data. So let's talk about what is a model. So suppose you have a set of input and output data here. Your input data is the x-axis, which just goes from 0 through 9. And your output data is the y-axis, which is a score. And suppose a client gives you this piece of information and says, hey, I want to build a machine learning model that's going to predict y based on x. And you dig in your, we won't have to dig in your machine learning bag of tricks. You can go back to 8th grade algebra, and you can come up with a potential machine learning model that could be useful to make this prediction. In this case, it is the equation for a straight line. It's also the world's simplest neural network. So the output, which is y, is going to be based on the input. And then during your machine learning training, you're going to try to discover, when you train the model, what is M and what is B. And so this is the basic model you start with. You take the data from your previous slide, and when you train the model, you get the following. You discover that M is 0.1 and B is 0.45. And that's how a basic machine learning project would work, by developing an algorithm that makes a prediction based on inputs and outputs. Okay, some common models you might run into with clients. Just going to throw out some couple terms here in case you hear those. Random forest for detecting fraud, multi-layer perceptrons for predicting sales. Those are feed-forward neural networks. Convolutional neural networks for image classification, and recurrent neural networks, or LSTMs, for natural language processing. Most projects you're going to want to work on, you're going to want to start with proven models and not take risks. Okay, well that brings us to the end of the first part of our presentation, and I tried to cover AI basics, and hopefully you feel a little bit more armed to go into a conversation and not be as scared and intimidated by this technology. So now, the second part, and the more fun one, is to figure out how do I identify opportunities with AI. So the billion-dollar question that many of your clients are going to have is, what business problems can we solve with AI? What can we do with this technology? Can this technology solve a particular problem that's challenging for us? This actually ends up becoming a pretty challenging question to answer, because there's so much technobabble and arcane technology associated with how people talk about AI. We just don't have a great language for talking to a business customer about this technology yet. So you can't sit down and figure out, what can I do with an LSTM or a generative model or an adversarial network? I mean, these don't mean anything in a business context. Well, it's actually a lot like the early days of the internet, when we also had very complex arcane technology like TCP/IP and CGI and Java and serverless and HTML. And if you were involved in the internet in the mid-90s, you see that even in business meetings, people were throwing a lot of this technology around without really even knowing what they were trying to do with it. But over time, we actually came up with more generalized ways and more generalized unifying concepts for talking about what you can do with this technology. I call these product patterns, because they are common ways of using business technology in a reusable fashion to solve a lot of common business problems. So we can talk about what we can do with HTML and web browsers and TCP/IP, but it's better to talk about some sort of unifying concept that allows us to do things like create e-commerce and content marketing and online publishing. And of course, in the internet, that the product pattern and the unifying technology for these underlying components is websites, right? And so when we do any kind of project now, we don't talk about what are we going to do with TCP/IP. We talk about a website we build for a customer. Well, it turns out we actually have the same kind of unifying product patterns in AI, and we've come up with 4 of them, and I'm going to go through each 4 of them with you. I will say this is the go-to skill in my toolbox when I get stopped by a client as I'm walking down the highway, and the CIO stops me in the hallway and says, "Hey, we got a project. We're thinking about using AI on it." And he starts spitting out, different ideas of what they want to do, and it's complex and there's people. In the back of my mind, I'm clicking off in the back of my head, which product pattern am I going to apply? Because if I can figure out what product pattern I'm going to apply to the project, that helps me continue the conversation and figure out whether or not there's an opportunity to create value with AI. So we're going to talk about 4 product patterns. The first one, and the most mature one, is computer vision. Computer vision is a ways of programming computers to be able to understand what's in an image. If you have the iPhone 10, you're probably pretty familiar with facial recognition as a biometric. That's a classic use case of computer vision. Now, computer vision was an incredibly intractable problem for computer science for decades. And as of 2013, if you gave a computer scientist a set of cat and dog pictures, and you said, okay, write an algorithm that's going to determine whether or not you can, whether or not a picture contains a cat or a dog. In 2013, you could do that with about 80% accuracy. Today, you can do that with 99% accuracy, and it's a trivial problem. Anybody, even people who can't do deep learning, can download a couple of pieces of code off the internet and solve this problem very simply. So what can you do with computer vision? Do things like classify images. So we do a lot of work with insurance companies, and so insurance companies are now using computer vision. If you have a damage to your car, you can take a picture, submit that to the company. It'll allow you to detect, what are the types of damage that are happening. You can do image segmentation, so identifying what's in an image and having the computer figure out, is this a car, is it a person, is it a bicycle, what's going on inside this image. And here's what that technology looks like for self-driving vehicles, right? Automatically detecting what's in an image through computer vision and masking. You can imagine that this is going to be a pretty important part of self-driving cars. I like this diagram. It's actually about 2 years old. It was from a research project produced by Google because it really helps give you a sense of how smart and how good this technology is becoming. So here's a particular picture of a project and a research report that Google published, and they wrote an algorithm to determine whether or not a particular part of an image is a kite or a person. And some of these are pretty obvious. If you look at the top center of the diagram there, that's obviously a kite, right? And the lower left-hand side, you can see images which are obviously people. I mean, it's not very hard. Just picking those out of an image is not a hard computer science problem. But if you look over on the far right-hand side of the diagram, at least on my right-hand side, where you see a kite 96%, person 87%, ask yourself how, with just a couple of blobs of like pixels, how did the computer know that that little black blob has an 87% chance of being a person, and those red and black blobs in the sky have a 96% chance of being a kite? Well, the answer is, if you haven't guessed it, it's because the algorithm figured out that people don't go in the air and kites don't go in water. So it learned context from the image. So if you want to look for opportunities in computer vision with your clients, if the company is doing something where they're already using images, they're most likely already looking at this technology because it's very quickly becoming state-of-the-art. So if they already have image technology, if they already have images, they're probably looking at using AI for some computer vision-related activity, or about to do so. More commonly, we see situations where you'll see a client that has an existing workflow or a business process, and you think to yourself, you know what, there's a way we could introduce pictures and images to this business process to make it easier. Maybe we can have our customers take a picture of something and upload it to a website. or they can do a screen capture of a particular problem. So this is where the creativity comes in as a business analyst. When you're helping your clients try to solve a problem or make a particular process more efficient, can you figure out ways to introduce imagery into the application? Data challenges. So the biggest challenge with computer vision problems is data labeling. And it's a challenge because it requires usually people to organize a set of training data by labeling exactly what is in it. So here's an example of a piece of software that someone could use to label an image and determine whether something is a cat or a cat or a dog or a person. This can be a pretty tedious process. Fortunately, people tend to be pretty good at it, and there are a lot of third-party tools and even companies you can outsource your data labeling to that can do this for you at scale. So creating and labeling training data is going to be one of your most expensive parts of doing a computer vision problem. Okay, the second product pattern, and my favorite, as you'll probably see from my enthusiasm, is natural language processing. Natural language processing is an algorithm or algorithmic approach for using computers to generate, understand, or interact with natural or human-generated language. So they're not structured data that's sitting in a database somewhere. This is the language that we create as people, either written or spoken. And I am so excited about NLP because the golden era has really arrived in the last 18 months to a year. If you're not working on an NLP-related project, I would be shocked if you're not doing so in the next 5 years. And the reason is pretty simple. Up until about 18 months ago, to do any kind of project in NLP was incredibly expensive. And it only was the Googles and the Baidus and the Facebooks that had the amount of money to gather up and organize the training data and to get the expensive computing horsepower to do anything with NLP. And it just wasn't practical for most business problems. I mean, most of the times when clients were doing a project, we're trying to figure out either to cut costs or drive revenue. And if the investment in the technology is millions of dollars, unless you're at Google and you're doing automated machine translation in Google Translate, it's usually not worth the investment. But about 18 months ago, a couple of researchers published this paper, and they came up with a technique for allowing you to do NLP with much less data and much simpler and cheaper computing power. And it really has opened the floodgates so that many, many more companies and companies like ours can go in and do projects with clients to help them use natural language processing. So I'm going to show you a couple examples now about the state of the art. This particular example was created by OpenAI, which is a nonprofit organization in California that was originally funded by Elon Musk. And they decided to build a state-of-the-art language model using NLP. And then they took this language model and they taught it how to generate stories. And all you would have to do is to feed it a first sentence, and it would generate the rest of the story. And here's an example of one of the stories that the machine generated. So the researchers fed a sentence, and the sentence is, a train carriage containing controlled nuclear materials was stolen in Cincinnati today. Its whereabouts are unknown. The computer then generated the rest of the story. And I'm not going to read the entire thing, but I'll read the first couple of sentences. The incident occurred on the downtown train line, which runs from Covington and Ashland stations. In an email to Ohio news outlets, the U.S. Department of Energy said it is working with the Federal Railroad Administration to find the thief. And then it has a quote after that, which looks like something that a government official would have said. Now, this is amazing for a number of different reasons, but let me just give you the punchline. This was not an algorithm designed to generate a story about stolen nuclear materials. This is a general language model that was designed to generate any kind of story. So you could feed it whatever first sentence you want, and it would generate the story after that. It's got a couple of other examples in OpenAI's website, which I would encourage you to check out if you're really interested. But it's just absolutely amazing how good this technology is becoming. And the algorithms that they use to build this technology and the techniques that they use, we're using those same techniques in our clients today. So we can take these pre-trained language models like this and apply them to our clients' projects. So the power of this technology is getting incredibly easy to use. Let me show you another example of how someone took a model like this and applied it to a particular problem. So there have been researchers that have been working on an AI challenge every couple of years. It was originally funded by Paul Allen, the late Paul Allen. And they were trying to teach an algorithm to take an 8th grade science test. And so here is an examples of the type of questions that it would be fed into the machine. The second one is, which form of energy is produced when a rubber band vibrates? Is that chemical energy, light, electrical, or sound? So these are like technical questions that, at an 8th grade science level, but I can guarantee you I have some relatives who could have a hard time passing this test. I mean, this is not cat in the hat type of questions. Well, they took the algorithm, they trained it in a number of different ways, and at the end of it, the algorithm got over 90% accuracy on this test. And so this graph here shows you the progress they've made over the past couple of years. 2014, they were able to get about 36%, that's an F. 2015, 58, that's still an F. 2016, 63, that's an F. And in 2017, 2018, they got Ds, and then all of a sudden in 2019, they got an A. So when I say this is why I'm so excited about this technology, because now we can take this very same type of algorithm and this approach, we can apply to our client projects, whether or not they want to sort projects or they want to classify email, whatever they want to do. So what can you do with natural language processing? You can just look at Wikipedia page. It has all kinds of examples. You can recognize speech. You can automatically route or categorize text. You can do more advanced search algorithms, maybe extract keywords or phrases out of documents, categorizing text. Let's route this email and tell me if it's going to violate one of our potential compliance policies or not. How to spot NLP opportunities with your clients. Really, we just suggest walking around and looking at how the company uses natural language processing in their business today. We find that our clients who go through this exercise, we usually come back with 20 to 25 projects or 20 to 25 opportunities for applying NLP. HR's got resumes, and operations is routing forms and documents, and legal has all kinds of contracts, and sales has forms filled out by the customers or free-flowing text. And marketing is information off the web they want to categorize. And call centers, of course, they have a ton of natural language available, because every time they talk to a client, they're listening or hearing language. So there's tons of opportunities in almost every business for NLP. Some of the data challenges here are the training data challenges can be pretty extensive. If your data is well organized, then it's fairly easy to build these models. But building that training data set is often the biggest challenge. One of the challenges is actually expert labeling. So earlier with the computer vision, you saw that image where I showed you how you could draw a box around the person who was playing soccer or football and decide whether it's a cat or a hat. Imagine how much more difficult it is to have a lawyer sit down and read through a stack of contracts and organize them based on which ones are relevant for legal discovery or not. These are much harder problems. Also, converting speech to text, the automated speech recognition. So if you want to do any kind of work with a call center, then you typically will have to work with a third-party vendor like Microsoft or Amazon to convert that speech into an image. Or if you have scanned images like scanned contracts, then you have to convert those images into digital text using optical character recognition, or OCR. So typically when we start a project, these are the kind of hoops we have to run through to get the data in the right place so we can start doing natural language processing with it. The third pattern, and actually the most common one that you're going to probably run into, because this is sort of the domain of more traditional machine learning without deep learning, is what I call next-in sequence predictions. It's using structured or tabular data. I call it next-in sequence predictions. Some people call this tabular data, structured data, or just traditional machine learning work. This typically comes up in the domain of you have IoT devices or sensors, sales and marketing tables. Maybe you're doing work with an online retailer, and this online user behavior, perhaps you're tracking the activities that a person does on a website or how they move the mouse, or maybe you've got logs in some particular server somewhere, you're trying to track the events that people use. Common next-in-sequence applications are predicting the future sales of an item based on past sales, classifying log entries. So is the server about to blow up or is it about to get hacked? We sift the log entries. Credit card fraud, detecting fraudulent transactions. Detecting anomalous events from sensors, so IoT devices, tons of next-in-sequence. and predicting which user will buy. Very common sales problem. They want you to rank their leads or tell you, you know, of all these people that I could talk to today, which customer is most likely to buy from us. The best way to think about opportunity or ways of whether or not it's a good domain for a next in sequence problem is to think about the stuff you normally see in a database, right? So in a database, you'll see dates and stores and categorical variables and numbers. That's what you normally see in a database. You don't normally see text, free-flowing text images. That's where we apply NLP, and you don't normally see images themselves in databases. So usually they don't come up in next in sequence applications. So how do I identify opportunities for next in sequence opportunities? First off, look around the company or the client and look for existing business processes where people are making predictions. You know, if you're working with a bank, maybe they're generating a risk score for a particular type of transaction or a particular type of way of organizing their financial instruments. So if you have any kind of existing system or processes that makes predictions, that's an opportunity for next in sequence. Look at the data dictionaries from your client. Just look at what they have in their database. What would you want to predict? Like, what would the client want to know? They probably have an entry for, you know, sales or some sort of other metric that drives business value. Would it be useful to predict that? Well, sure. Usually most businesses want to be able to predict what their customer behavior is going to be or how much sales is going to happen. Look at your KPIs, your key performance indicators. What does the company measure already? What do they track their people to? Those are great opportunities for using machine learning, because if you can help them predict what those metrics are going to be, you give them an opportunity to intervene so they can change whatever they're doing to be more successful. And finally, always keep on the lookout for new data sources. There are tons of third parties out there that are producing weather data and credit scores and commodity pricing. There's lots of new emerging data stream companies, and you can leverage the data from those companies to add to your existing models and build better solutions for customers. If you do any kind of work with data scientists, at some point you'll probably hear about data wrangling and feature engineering. Those challenges come up in the domain of building a next in sequence model. So usually gathering enough training data and labeling data is not a problem when you're doing next in sequence activities. The customer usually has tons of data in their databases, and they usually have a field in their database of what they want to predict. What the challenge comes in trying to take that data and organize it in a way that allows the data scientists to do a more effective job of training the machine learning model. So here's an example of date and beer sales, right? Now, from just looking at this particular table, it's not obvious why on January 5th of 2013, why there was a lot more beer sold than on any other day. It's not obvious looking at this particular graph why that might be the case. And a machine learning algorithm could not easily figure that out. But if you do some simple feature engineering and you extract the day of the week from that date, suddenly the answer becomes pretty obvious, right? We know why there was more beer sold on the 5th, because it was a Saturday. That's the kind of work that your data scientists do to derive features or feature engineering to help feed a next in sequence model. So when you work with a customer to plan out a project that's going to use one of these approaches, plan on several weeks and months for the data scientists to spend doing data wrangling and feature engineering. It looks like we're about right on time here. The fourth product pattern, the one I'm going to spend the least amount of time on, is called collaborative filters. These will typically come up if we work on building a recommendation system. A good example is the original Netflix recommendation system. So if you have a situation where you have a lot of users and you have a lot of activity that those users do, you can look at the algorithms can look at the behavior of previous users and predict what they're going to do in the future. So if I sit down and watch a bunch of movies on Netflix and build up a movie queue, just by looking at what I've done, what I like, what I didn't like, what I stopped earlier, what I watched again, based on other users of Netflix that are similar to the way that are similar to me, you can predict what I'm going to watch next. So it comes up in recommendation engines, and sometimes in some advertising and e-commerce applications. So those are the four product patterns. A couple other comments. These models, you can combine these product patterns into the same type of model. And when I first saw people doing this, this struck me as kind of crazy. As a software engineer, you get very used to building specific rigid things, and software doesn't easily just fold and munge into something else. But in the case of neural networks, you really can take computer vision data and natural language text and stuff from a database, and you can just kind of jam it onto a model and predict things. So here's an example of how Google did that. They called it looking to listen. They took two speakers on stage who were speaking at the same time. They took their audio, and they used computer vision and natural language processing to automatically split the audio into different streams. And there's a good YouTube video on this if you want to take a look at it. Just go into YouTube and look for looking to listen, and you'll see the example. So there are a couple of emerging product patterns. This is really the main ones we've been using over the past couple of years. We're starting to do some work in a couple of other areas. One of them is reinforcement learning. That's a process for using self-feedback to solve a particular type of business process called a Markov decision process. You may have heard about that when Google used reinforcement learning to beat the human world champion Go player, Lee Sedol. This made a popular headlines a couple years ago because the game of Go is much more complicated than chess. Another area is generative models. You may have seen these deep fakes, people talking about those on the internet. Here's an example where someone took Amy Adams on the left and they're able to generate a Nicolas Cage model on the right. So, it seems like creepy, and unfortunately, most of the internet, the internet talks about generative models and its deep fakes and all the, this other creepiness. But actually, the engineering technique is pretty useful because it allows us to create new types of algorithms without using tons of data. Okay, so a couple of the supplemental things. That's really the main. Those are the main two topics I wanted to cover. I'm going to give you a couple of the pieces of supplemental information for the BAs based on the questions. The first one is in the book we have an entire chapter, chapter 3, dedicated to the AI canvas. I didn't have enough time today to go into it, but once you've used the product patterns and you work with a client to identify an opportunity with AI, the AI canvas is your framework for figuring out, is this something we should pursue? What's the opportunity? If you've used the business model canvas from Alexander Osterwalder or Ashmore's Lean canvas, then you're probably familiar with this type of approach. It allows you to quickly document, in a single page that's easy to modify and digest and understand whether or not a particular AI opportunity is worth pursuing. So in our workshops, in our workshops with our clients, we have them go through exercises of filling out one of these clients for an AI idea that they come up with. But if you find yourself, this is Creative Commons, so feel free to take it and use it on your projects. If you find yourself in a situation where you're talking about an AI project, even if you don't use this canvas, this format, the questions in the boxes here are going to help you organize your thinking. They're going to help you identify things like policy and success criteria, the things that the engineering team doesn't normally think of when they start a project. Okay, I took a look at your knowledge areas, and I took a look at some of the questions that you were asking, and I tried to come up with some highlights that I would leave you with for business analysts. And this is the one slide that you may want to take a picture of because it's not in the book, because I made it just for you. So 3 ways that I think AI is going to change the work of business analysts, or how business analysts are going to have to change to get to adapt to an AI world. And the first one is a transition from thinking deterministically to thinking probabilistically. So AI models, in traditional software development, there are very rare situations where we just can't get the software to work unless it's just poor execution. Usually with enough time and money, you can get the software to work. There's not a fundamental scientific risk the way there is in something like biotechnology, where you don't know if this model is going to, this molecule is going to cure cancer or not. In AI and deep learning, we often don't know how well an algorithm is going to work until we try to do it, until we set it up and test it and try to actually build models in a notebook and have a data scientist try something out to see if it's going to work. And that takes an investment of time and money. And stakeholders don't like that. They don't like uncertainty. They like clarity. So this is a way you're going to have to communicate with your stakeholders and help them understand the uncertainty associated with their project and get them to take incremental steps. Like before they try to go hog wild and build an AI system, have the data scientists and machine learning engineers build a system, build a simple system using their tools like notebooks on historical data, and test to see how well it will work. The second area is that AI projects typically involve a smaller group of highly skilled people who work at a faster pace. So if you're used to working in large software projects where you have people doing requirements and documentation, and you have release cycles and release notes, AI tends to be a lot more iterative and a lot faster and a lot smaller. Most of the energy goes into organizing and designing data sets and tracking data and measuring performance. You don't have as much documentation of requirements just because the developers don't work that way. They just need the training data to train the models. And so that really brings us to the third point, is that being an effective BA really requires having some harder skills, particularly in statistics, data visualization, and data processing. So to the degree you can talk about probabilities and validation sets and confidence ratios and p factors and AUCs. You don't have to become a statistician, but if you can get fluent in what this language is and what it means, it's going to be a huge help to you to help you get a leg up on one of your client projects. And also data and data visualization. A lot of times data scientists are good at building the models, but they may not be great at explaining it. If you're able to go in and use the fundamental tools, or even use something like Tableau and build data visualizations to help explain to stakeholders how well a model is working or not working, it's going to give you a great set of skills to have in your toolbox. Okay, I think I am 2 minutes over, so I apologize for going slightly longer. I'll stay a little bit longer for any questions. If you do want to reach out and talk to us, or you want to connect on LinkedIn, please mention to Russ Rands or myself. You can connect with either one of us on LinkedIn. Just mention that you attended the BA, the Trailblazer workshop here, just so I know that I recognize you. I don't usually accept LinkedIn invites from people I don't know. And I want to accept one of yours. So if you send me one, please let me know so that this can be lost on my feed. Thank you very much, and we have Russ's contact information. If you want to find out any other information about us, what we do, if you have a particular client project and you want some quick advice as to whether or not AI can help, we'll be happy to jump on a call with you. That's about it for Have, so time for questions.
That's great, Kevin. Thanks a lot. So do we have some questions in the chat window right now?
Questions in the room?
I have the questions that you sent in advance, but
well, to start off, Kevin, maybe you could talk a little bit about, as BAs, how do we help stakeholders gain trust in the model?
This actually comes up. This comes up a lot. The idea of model interpretability and helping you understand whether or not it's going to be, it's going to be worthwhile. I hear this problem talked a lot, but honestly, I almost never run into it on a project. I did speak with someone that works at a bank today that was in a process of trying to brief regulators and help them understand how neural networks work. But normally the way I explain it is the following, that machine learning models are like any other business process. Like, we don't fully understand exactly how they work. We don't understand exactly how our existing business processes work. We do a lot of work with insurance companies, and the executives can't tell you really how underwriting works, right? So they kind of know what's going on, but you have a bunch of people doing a very complex task. These models end up being the same way, although they're a bit easier. I find that if you sit down with an executive and you show them the training data that you use, the inputs and the outputs, and you show them the model that you built, and you show them how you tested it, and the validation, and data scientists, they've got tools for doing all of this. Show them that how you validate that the model's going to work, and show them examples of how it works. That's when you gain confidence. I find that a lot of the black box, neural network discussions, I see people talking a lot about that, but honestly, I don't run into it that often on projects. Most of the executives are trying to increase money or cut costs, and they just want to know if it works. And if so, they want you to get up and running as fast as possible. So beyond that, there are some more technical tools. There are software packages like Lime, which allow you to interpolate machine learning models. But mostly, I find a good conversation takes care of most of it.
That's great. Do we have some questions in the chat window there, Kevin?
Where can a traditional BA start to get involved and learn more about AI? So at the risk of pandering my own stuff, just because I actually believe it, I think our book is probably the best place to start. And just because you can flip through it in an airplane ride, and we do try to cover a lot of the basics. You heard about 50% of it today. Chapters 3 and 4 go into a lot more detail. Chapter 3 goes into the canvas and how to vet whether or not there's an opportunity there. Chapter 4 talks about project teams and getting your first project off the ground. And there's a particular role in there, I call it AI product manager, but you could apply what I say about product managers, you could apply all that to being a BA. It's all the same. So I'll give you some advice there on the ways you can, the kind of things that a product manager or a BA would do as part of an AI team. Once you get through some of get through our book, the next thing I would suggest doing is taking some basic online courses in statistics, data visualization, data processing. Get to know the basics of the language, and then if you can get through that, just take a machine learning 101 course. Udacity has some nice ones. Don't go through some complex, hard deep learning problem. Do a basic machine learning course where you're going to go through and fill out exercises on the screen. Because simply going through those challenges is going to really help you understand how data scientists work. So that's where I would start. Will there be standards for data labeling? That's interesting. I don't know if there are necessarily, well, I think each different, let me see, I'll answer it differently. So people are building training data sets where they have built up labeled data. I don't know if it's necessarily a standard, but a good example of one is ImageNet, where they have hundreds of thousands of images that are categorized into one of 1,000 image categories. So like chair, fish, soccer ball, things in a picture. So that's an example of a standardized data set that someone created, and people are starting to create some of those for NLP. I don't know if there are standards the way like an ANSI standard. I haven't heard of anything like that, but maybe there is one under development. What are some of the tools that could provide the greatest assistance to a business analyst working on an AI effort? To the degree that you are able to understand how to use a Jupyter notebook, you will become a lot more valuable to the project. So Jupyter notebooks are the tools where the data scientists do their programming. It allows them to very quickly run experiments, write little piece of code, test things, try things out, delete them, run them again, and in a workspace. It works almost like a scientist notebook. If you're able to take a simple course and learn how to use one of those tools and learn how to use some of the data visualization libraries, some of the common Python libraries like NumPy and Pandas, that will help you understand what they're doing. And you don't have to be an expert in creating that software, but if you can look at a notebook and have a decent idea of what the data scientist is doing, and more importantly, being able to jump in and create additional charts, summary diagrams, or documents that complement what the data scientist is doing, that can be a big help. Any ideas for free software for visualization and training? I do not know. I will just have to Google it. Sorry. I don't know any good courses out there, but Udacity, Coursera, Udemy, I'm sure there's some out there. What resources on a typical AI project team look like? What is the composition of the AI team? I cover this in chapter 4 extensively, but I'll give you the punchline right now. A typical AI project has 3 types of skills. You have the data scientist, which is the person who actually builds the models. They do all the model development, the design, and the testing, and the data munging. You have the data engineer that takes that model and deploys it as a piece of software. So they write all the Python code that pulls data from upstream pipelines and runs it in an operational center and spits out the output to a system, and they can do that at scale. That's the data engineer. And the third skill is what I call AI product manager. You could probably call that a business analyst as well. And that's the person that has to do everything else. And that's talking to stakeholders, working with stakeholders to evaluate results, trying to figure out what the interfaces are going to be, getting new data sources. It's basically talking to the general counsel to figure out if we've got the legal rights to use a particular data set that the data scientists want to use. It's everything else it takes to get one of these projects off the ground. And I think I have a list of like 14 activities in the book. Resources. How does an AI project lifecycle differ from a traditional software development project? How do you approach it following an agile method such as Scrum? Okay. The biggest difference between traditional software development and AI is in traditional software development, you do not have this process of discovery. And so you normally, traditional software, sit down with the customer, gather requirements, and a developer builds it, and on and on and on you go, right? And you can do that as a waterfall, or you can do it as an agile process. In AI, you have this added activity where the data scientist has to go discover and create the model. They have to go figure out, what can we do? Is it going to work? And so you have to account for the weeks of effort that that person takes to be able to actually go through that process and come up with a model. Additionally, you have the challenge of a data scientist comes up with a model, it's running inside of a notebook, it does a particular prediction. You now have to figure out how to translate that into your data engineers or your IT or operations. And those two people are speaking completely different languages. So this is often where we find our clients struggle with the most challenge. It's not actually doing the machine learning modeling and building the models, it's taking those models and deploying them into production. Because although they both might be writing in Python, the way data scientists think about software and the way data engineers think about software is radically different. Data scientists are trying to discover new things, and they're creative, and they're looking at data, and they're munging it, and they're coming up with great ideas and more predictive algorithms, and they got all this power. Data engineers, they want predictability and scalability and process and documentation and clean interfaces and well-written code. So there's still quite an impedance mismatch between those two skills. All right, there's a lot of, let's see if I can get to all these here. I can imagine that a training data too narrow will provide poor results in the end. How do you ensure this data set is wide enough? Correct. Getting enough training data is one of your biggest challenges. That's what your data scientist has to figure out. You have to give that to your data scientist. They have to tell you how good the results are. I've heard people say things like, well, a good starting point is 10,000 labels or 50,000 labels. But I'll be honest with you, it really depends on what you're doing. We've done some great work with a lot less data than that. It really depends on the domain. And the more important question is, do we feel like the data that we have does a sufficient job of being correlated with whatever the output is? So garbage in, garbage out. Let's see. How do you ensure that the data set is wide enough? I don't know if there's a way to ensure it. You just have to go get more data, spend more money. In Hungary, Telecom trained an AI to design an optimal telecom network. It did not look at all like what its engineers would build. Problem, the AI could not explain how it chose the design it did. How do you build credibility into the results AI delivers? So for me, if I was in that situation, I would just try to do it empirically. I would say, all right, let's run a test to see which works better. Maybe that's too, but honestly, that's usually how we end up working. We don't get into philosophical debates with people who've been doing something a certain way for many years. We say, all right, let's just test it. Maybe it won't work. Most organizations have a lot of bad data. Ooh, no kidding. How do you get buy-in from executives to push their teams to clean up their data and maintain clean business processes so AI will be successful? So the first, usually, I might give you an answer that's going to surprise you, this question. So you're right. Every company has data problems. So you have data stovepipes and data stovepipes of excellence, and data is a mess. And go into any company, they're going to tell you all their data is a mess. The worst mistake I see is companies trying to get started with their AI efforts by saying, well, we're going to start by fixing our data, right? There's a couple of reasons why that's bad. One is that it takes 10 times longer than you ever think it's going to take. Eventually, the CFO gets frustrated with wondering what the heck, how much time you're spending on this project. It only delays your AI efforts, and you're never done, right? That's the thing. It's like you're never going to get there, so you're always going to have messy data. What we try to do with our clients is to use the data that they have to the most effective way they have. So if you're going to try to build a model, find some way to take your existing data, pull a historical data set, give it to your data scientists, and have them start doing training and figuring out whether or not there's a valuable model you can generate. Once they do that, they can figure out which unique data points are going to be the most valuable. And then when you go to try to deploy your AI system, just focus on that data. Just clean up the stuff you're going to need for the AI model rather than try to boil the ocean and fix all your data. There's been a couple of high-profile head of AI executives who lost their jobs because they, step one was fix the data, and a year and a half later they had nothing but more data problems. Since these are new roles, data scientist and engineer, how as an enterprise can you trust the skills of people? Yeah, this is a tough one. How can you trust the skills of people? Yeah, well, I'm probably not the best person to ask, because usually by the time we brought in, there's already there's always some. I mean, we're brought in because they want to accelerate their AI efforts at our clients. So even though they may have good data scientists and they have a team, for whatever reason they want to bring an outside party to help them get things up and to get things going faster. I guess I have found that there's a lot of people that can learn how to do this technology within an organization. Most companies figure that they've got to go out and they've got to go recruit off the shelf and got to get, got to recruit MIT, PhDs and Stanford PhDs. We've got to pay Google salary. And I would actually encourage you to try to use the resources that you have at your company. In particular, try to find the people who are already doing this. There's a lot of people who love this technology, who are spending their evenings and weekends taking online courses and building machine learning models and entering Kaggle contests. If you look for those people, they've already self-selected. They're passionate enough about this work to do it on their evenings and weekends. Give those people a shot. See what they can do. And usually when we work with a client, those are the people we try to help them find. Help them find the people who've got the aptitude and the interest to do this work and give them opportunities to succeed. What are the key controls to ensure a successful AI development project? So the key controls, so for us, the first one is that we just time box the effort. So, how long is this project going to take? No more than 3 months. So from the time we get data to the time we start building models, we time box it to 2 to 3 months. And that forces you to make choices. And that's what I would suggest you do with your internal teams as well. Don't let them come back and tell you what they can do in 8 months. Ask them to see what they can do in 2 weeks. And that's going to force them to be creative and try to get early results using the off-the-shelf data that they have. Data scientists, it's like what I like to say is, the CFO never has enough money, the project manager never has enough time, and the data scientist never has enough data, right? So they're always going to want more data and better data because then they can make a better result. But oftentimes that can really extend the length of your projects. So the best tool we found is to really just time box the initial release to 90 days to see if you get something out the door. We put AI models into production in 62 days for one of our clients, and that's from the time that a project started. So if you're creative about how you use your existing data and what you go after, you can do these things pretty quickly. And then where is the intelligence factor in AI? I guess I would encourage you to go back and look at the 8th grade science test example that I showed, and look at how good the technology is getting, and the fact that it can already get an A in an 8th grade science test. Ask yourself how good this technology is going to be in 2 to 3 years. So that's how, at least at NLP is where I'm seeing the emergence of the intelligence. Can you provide some more examples in AI in operation? Yeah, this is, well, yeah, this one I probably can't do in 30 seconds, but let me just say that one of the biggest challenges that we have with our executives is they want to know right away, what can I do with AI? Can you give me use cases, examples of how I can use the technology? And unfortunately, it's not that easy. That's why we created the product patterns and the canvas to kind of generalize, give people a generalized way of coming up with that problem. But I mean, you will find almost any business problem you can imagine, you will find people that are working on AI to try to be able to solve it. That's not always successful, but I'd say if you're looking for ways, examples of successful problems in operation, start with the 4 product patterns that I've identified: computer vision, natural language processing, stuff in databases next to sequence. That's where you're going to find your low-hanging fruit. Doing some new deep reinforcement learning paper that just came out last week, probably not where you want to start. How can we communicate the potential value and risk to stakeholders in order to increase buy-in? Potential value and risk. Well, so I think I kind of covered some of that during the presentation. Value start with the output, start with you trying to predict. That allows you to figure out whether or not it's something valuable, and then use the AI canvas. I mean that canvas is designed to help you answer that question. Designed to figure out how long it's going to take, how much cost, what is the risk, do we have available models off the shelf we can use, what's the state of our data, do we have the legal rights to do it. That'll help answer some of those basic questions. And since it's 8:21, I think I've gone 1 minute over. Maybe a good time to wrap it up there, Ted?
Yeah, absolutely. So thank you very much, Kevin.
Yeah, thank you guys. Again, really appreciate how well organized this was. You made it very easy for me, and thank you so much for the great questions. And like I said, feel free to connect with Russ and I on LinkedIn. And if you have any questions about a client project you're working on, or there's something we can help you out with, please feel free to reach out to us.
That's great. So thanks so much, Kevin. Thanks for everybody, and have a great night. We'll see you next time.
Thanks, everyone.